Okay, here we go. Let's do that. Let's do this. Where's that? There it is. There we go. Okay. All right, we're gonna get this here. Yep, yep, yep. All right. Starting there. Get there. Okay. All righty. Looks like I got a couple of minutes here. Oh. Yep, 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 yep. Got a few more people. uh, actually, when did you send it, Eric? If you sent it late last night, then I haven't looked at my email yet this morning. So, but I will take a look at it. I will take a look at it after. Oh, you sent it a couple days ago? Probably then. Yeah, I think I did see your work there. Actually, no, I'm pretty sure. Yeah, I'm sure I saw your work there. Okay, that's cool. That should be just fine. Not a problem, my friend. Not a problem. Cool. Yeah, apologies for the late start here. Got a little late coming in, but we should get our stuff done here today, so shouldn't be all that bad. Okay. We'll wait for another minute or so, and then we'll go ahead and get started. We'll have other people start trickling in before then, so that'll be okay. How was everybody's weekend? I hope everybody was okay. Okay, let's go ahead and get started here. We'll have a few more people come in if they need to, but that's all right. We'll give him some time. All right. Okay, let's get started today. Welcome back to Tuesday. Hopefully everybody had a nice weekend. All right. So today we're going to continue moving forward here from where we left off last time. Last time we talked about multiplication. We talked about multiplication of fractions. Okay, we talked about applications of multiplication, and we also started on division of fractions. And we only did a couple of examples of division, but we didn't get to more of the meat and potatoes of division. So that's what we're going to be doing here today, as well as we're also going to be talking about more applications with more applications in reference to mixed numbers with multiplication and division of fractions. And if we have time, we'll get started here with adding and subtracting of fractions. All right, so we may take a look at that at the end there. So just to let you know, we're going to get through, so at least just to let you know here, sections 2.7 and 2.8 is what we're definitely doing here today. And then if we get further enough, we'll do section 3.1 if we get there. So just to let you know, you guys usually ask me, what sections we're covering here today. These are the sections that we'll cover here today, um, specifically. Okay, that way you guys are in the loop. Okay. All right, so today let's go ahead and start here with talking about dividing fractions. So let's remind ourselves exactly what dividing of fractions actually entails. Okay, so let's do it. All right. Okay, so dividing fractions, there is going to be one rule to dividing fractions, and we'll talk about, of course, expanding upon that. But what is the rule for dividing fractions? It's fairly straightforward. Okay, so let's go ahead and type that out one more time to give you a reminder from what we did last week. So that's going to be, again, if we have, say, A over B, and we divide that by, say, again, C over D, then we don't, again, we're not dividing straight across. We can't actually do that. But unlike multiplication, but we can switch it to multiplication. Okay, so one thing that we can do is we can swap this to multiplication with a consequence, of course. And that consequence is that we're going to flip over C and D. So we're going to have D over C, and then essentially multiply straight across right after that. So that is the general rule here for division, is going to be looking just like that. And don't forget here that D over C, and I'll put that here, D over C specifically is going to be, is the reciprocal, what we call the reciprocal here, of C over D. Get that last one there. Okay, so that's what we have here. D over C is the reciprocal of C over D. Okay, so we just flip the fraction over. We put the numerator in the denominator and the denominator in the numerator. Okay, so we're going to cover, of course, lots of examples about how to do division here, of course. But first, before we go ahead and do that, we looked at a couple of examples last time. But let's cover some of the other basics here just to kind of get it down, and then we'll go right to examples here. A few more examples after that. Okay. So let's look at this first one here. Okay, so it says to find the reciprocal of 1/4. So let's find the reciprocal of 1/4 using our rule here. Okay, so let's find reciprocals. Okay. So how about the reciprocal of 1/4? What's the reciprocal of 1/4? What's that going to be, according to letter A here? This is, by the way, this is page 101 in the packet there. So 4/1. That's right, Hannah. Nice. Now, one more question for you, Hannah. What's another way to express 4/1? What's another way to write, I guess, 4/1? So another way to write 4/1 is just going to be 4. Okay, so just to let you know, that's just going to be 4 at the end of the day. So the reason why I ask you that specifically is because just to keep in mind that we're going to use this little fact in other problems. All right. So, no, it's fine. Don't worry about it. Don't worry about it at all. No, this is important. I just want to be sure that we recollect we could write 4/1 is 4 because we're going to use this fact here in dividing fractions. And you'll see exactly why we need to rewrite them. So, we just want to be sure that we got things going just based off of that. Okay. Let's try another one. Okay. Let's try letter C there. Let's try 5/3. Okay. Well, 5/3, what would the reciprocal of 5/3 be? What's the reciprocal of 5/3? 3/5. Good. 3/5. All right. Spot on. Totally agree. Okay. Now I'll throw one more here into the mix. Okay. So I agree with 3/5. Everybody's got spot on here. Let's throw it into the mix here. Now let's recall the first example we did. That'll be helpful for this one. So how about 9? How about 9? What is the reciprocal of 9? Okay, that's how we can rewrite 9. So you're on the right track here. We can rewrite 9 as 9/1. But what's the reciprocal of that? Right, exactly. So what we're essentially doing is we rewrite 9, but then the reciprocal of that is 1/9 as a result because of that rewrite. So you can see the importance of rewriting it just like that is that we could go ahead and just flip it over once we write it as 9/1 first, and then flip it over, and that's why we get 1/9. Are there any questions about that? Again, type no in the chat if you'd like me to move on, or again, type out your question if you have one. Everybody else all good? Any questions from anyone? Okay, go ahead and move on. Let's go ahead and try some problems out, okay? And we'll see how it works out, okay? Can we do one more? Sure, absolutely, we can do one more. Not a problem. Let's do, let's do, yeah, let's do that one. Let's do 5/11. Okay, so all we're going to do here, Yvonne, is just go ahead and flip it over. Okay, put the number in the numerator in the denominator, and put the number in the denominator in the numerator. That's right, so it'll be 11 over 5. That's correct. So that is going to be the reciprocal, as I'll say often here, the reciprocal of 5 over 11. All right, now we're going to take this idea that we have here for the reciprocal, and now we're going to, well, I'm going to tell you that in just a second. So the reason why we do this here specifically is because we need to apply this to the division of fractions. Yeah, no problem. It's all good. Okay, so let's go ahead and take a look at an example here by dividing one fraction with another. So let's look at this letter B here. We have 4/5 divided by 3/10. So I'm going to type this out here in our little chat box, dude. Okay, so this is where we have 4/5 divided by 3/10. Okay, now I'm going to talk about some of the things here that are going to be rather important, okay, when we do say a question like this, or if it's written in this way, because sometimes it's written, say, if you see here, it could be written with the division symbol straight up just like this, or it could be written just like this. We say 4/5 over 3/10 like so. So exactly how do we, sometimes it can be confusing because it looks like four numbers just kind of stacked on top of each other. So one of the things that I always suggest people to do is if you see a problem that looks like this, looks like something stacked on top of something else, what's a good idea for you to go ahead and do is to put parentheses around each of the fractions. That way you can keep organized. And maybe if you prefer, rewriting it the way you want. So, for example, here, if you put the parentheses around here, you can rewrite it as, again, now that you've differentiated the fractions here, you can say you have 4/5, just a different way of writing it, but same meaning. 4/5 divided by 3/10. Okay, so with the parentheses here, it's a little bit easier to see what the two fractions are if you're having trouble seeing how to separate them out. Okay, so that's one thing I'll put here on our notes. Okay, note here, separate fractions with parentheses, so you know which fraction is which. So okay, so that's one of the things that I suggest there that can be potentially fairly helpful for you at the end of the day. Okay, so oh well, that actually slotted in just fine. Okay. Okay, so let's go ahead and now rewrite this one more time. So we're going to rewrite this as 4/5, and then we're going to change the division into multiplication, and then we're going to do 10 over 3, just like so. Okay, so this is what we have here so far. All right, so we just flipped we just took the reciprocal of the second fraction and we made it into a multiplication problem. Notice the first fraction here does not change, okay? So that will not change at all. Just the second fraction reciprocal will make it a reciprocal, and we'll change the division into multiplication. Okay. Yes, this is always true, Yvonne. The first fraction will not be touched, but it'll always be the second fraction that will take the reciprocal of. That's the consequence of changing it from division into multiplication. So if you think about it, the whole is like the numerator, but the thing that you're dividing by is the denominator. That's why that'll change respectively. Okay. Now let's bring up a 4/5 divided by 10/3 there. Okay. All right. Oh, multiply. Sorry. Sorry, that should be multiply. My bad. Okay. Now let's recall here. Let's recall here about how we deal with multiplication of fractions. Remember that we want to be able to possibly pare down some numbers, again, reduce them down before we multiply. Okay, so we're still going to employ the same technique that we talked about in the previous sections when it came to multiplying fractions together. So do we have any number in common that has a common factor in the numerator and denominator that we can reduce down? Okay, 5 and has to pair up with a number on the top there. 5 and 10. Good. Okay, so 5 is just half the battle. Yeah, 5 and 10, right. So we're going to divide each of these by 5, since that's the factor in common here. So remember, 5 divided by 5 is 1, and 10 divided by 5 is 2. Then we just go ahead and rewrite what we have here. So we have 4 over 1 times 2 over 3. Multiply straight across now. So our final answer here will be 8 over 3. Okay, and that's our final result for that. Okay, any questions about that example? We're going to do some more examples, of course, but just showing off the basics here once again. Any questions at all so far? Yeah. Oh, okay. That's fair. So in this case here, if we get 8/3 as our number here, as our fraction, as our answer here, then we may need to change it to a mixed number. So that's a very fair thing to say. So changing 8/3, you just have to do 8 divided by 3. So again, that goes in 2 times. So we're going to get remainder 2. So just the same thing as we did before. So this is our big number here at 2, our numerator of 2, and our denominator of 3. So you can always rewrite that as 2 2/3 at the end of the day. So if they ask you for a mixed number there you go. Maybe it's been a while for you, Tom. How are you this morning? All right, let's do another example. Okay, I might have to choose something without that. All right, yeah, that one's okay. I'm doing very well, my friend, very well. All right, let's try this. All right, so here we got 5/6 divided by 7/12. Okay, now to make things easier, let's go ahead and put each fraction in parentheses. Okay, so again, just so we can reduce the amount of confusion here. All right. So, all right. So if we change this over, to multiplication, all right, what would this look like if we change this to multiplication? So we have 5/6 divided by 7 over 12. How would this look? All right, that's right. Nice job. Nice job, Yvonne. That is correct. Absolutely spot on. That is absolutely correct. So 5/6, because the first fraction does not change, and the second fraction is the only one that flips over. That'll be 12 over 7 once we change it over to multiplication. So let's add that as a note, just so we can clear up any more confusion. Yeah, that wasn't meant to happen, but okay. Let's undo that. Oop. Okay. Sorry about that. That was not intentional. Okay, so let's put a note here. Note, um, only the second fraction flips after we change to multiplication. Okay. All right, let me retype the problem here because it got deleted. My apologies. Okay. Okay, and we got this 5/6 times, again, 12 over 7. All right, so this is what we have here so far. Now, can we pare anything down here with this problem? 5/6 times 12 over 7. So let's go back to our drawing board here. So 5/6 times 12 over 7. Is there any number in common between the numerator and denominator here that we can reduce? Any common factor? 6 and 12 is correct. Good. That's right. So we're going to divide each one by 6, since 6 is the common factor here. So we're going to get 1 here, and we'll get 2. Absolutely right. Okay, so here we get 5 over 1 times 2 over 7. So here we get 10 over 7. Okay, we divide by 6, yes. And so here we have 10 over 7. And so if you were to make this in a mixed number here, 10 over 7 would be 1 and 3/7. Okay, so if you want to make that a mixed number there, because that's what the question asks you on the homework, then perfect. That would be 1 and 3/7. And then that would be your final answer for that problem. Any questions about that so far? I'm going to do another example, of course, but any questions about that one? So hopefully that one is a little bit easier. Well, it's not too bad. Okay, let's go ahead and do the next one then. That's not a problem. Okay, so the next one we'll do here is going to be, as you see on on the screen here, you can see 2/3 divided by 6. We're going to go ahead and do that one next. Okay, so uh, okay, how did things got I see. Um, yeah, just hang on, Tracy. If you could just email me, and then we'll get things squared away there. I'll square things up with you. It shouldn't be too hard to get that going since we talked last week. So no worries, okay? So you're in my yeah, your email should be on 'cause you're on my 97 course. So yeah, it should be so it should be in Blackboard, but I can here, you know what? I'll send you a thing here because you're in my 97 course. All right, I sent you a whisper there, Tracy. Should be good. All right, let's look at this next one here. Okay, next will be 2/3 divided by 6. Okay, so let's do 2/3 divided by 6. All right, so what's the key here in this problem? The key here in this problem is to rewrite 6 once again. So can anybody tell me, how can I rewrite 6 again? All right, 6 over 1 is correct, right? That's correct. So we're going to rewrite it as a 6 over 1, actually. Okay. So we're going to have 2/3 times, not times, sorry, divided. Yeah, I've got that divided by 6 over 1. Now we want to change this over to, you got the reciprocal right there. The reciprocal is 1 over 6. That is correct. So we're going to change this to 2/3 times 1 over 6. Okay? And we're just going to go ahead and see if we can reduce it down and then multiply. So do we have anything in common between the numerator and denominator that we can reduce down? 18 over 3? No, that's for adding and subtracting. Okay, 3. 3 and divide 3. But I can't divide 2 by 3. I can't divide 3 and 6. Those are on the same level. I have to have it 1 on the top and 1 on the bottom. So that's why 2 and 6 have to be our pair, because I need one number on the bottom, one number in the denominator, and one number on the top, one number in the numerator, and they have to share a common factor. So it can't be the same. It has to be different sides. But we are going to divide by 2 here in order to clear that up. So we get 2 divided by 2, which is 1, and 6 divided by 2, which is 3. So we get 1 over 3 times 1 over 3, which is equal to 1/9. Okay, and that'll be our final answer here for this problem, 1/9. Any questions about that? Hopefully that isn't too bad. let's go ahead and do one more with just numbers, and then we'll move on to some applications, okay? All right, you guys guide me here. Okay, so can anybody tell me, how can I rewrite 3/8 divided by 4? How should we rewrite 3/8 divided by 4? Could you have just simplified the answer to 2/3 times 1/6, changing it to 1/3? So the reason why I changed it to 1/3 times 1/3 in that previous problem there is because of the fact that we wanted to reduce the answer prior to actually multiplying straight across. So what you would have gotten is, you would have gotten, if you'd multiply straight across, you would have gotten 2/18. And then you could reduce by dividing by 2 in the numerator and denominator and gotten the same answer, 1/9. Basically to make the process easier, so we can essentially not have such huge numbers and confuse ourselves, that's why we reduce before we multiply straight across, so it makes the process significantly easier to do. So we have a reason why we don't want to do it necessarily the first way. That's just a way we can, again, of course, rewrite the problem, but then we do the reduction before we do the formal multiplication straight across, and we could get our final answer. So you don't have to do the reduction at the end. You can do it in the middle of the process with smaller numbers, which should be easier to handle. So we're just trying to do it as lazy as possible. So that by far and away is much lazier to do, which is nice. 3/8, okay, agree, that's 3/8. Then what? 3/8. What should this be? Times 1/4, good. All right, that'd be divided by 4/1, right? And so that should be times 1/4. Both answers are correct. Very good. All right, I agree. So we put the 4/1 so that it helps us see exactly how, how that should be meted out. And then that'll allow us to change we'll change it to the reciprocal of 4/1, which is 1/4. And now we just see if there's anything in common between the numerator and denominator. Now here's the trick behind this one. This one doesn't have anything in common. 3 doesn't go into 8, and 3 doesn't go into 4. So in fact, we're just going to multiply straight across because there's nothing to reduce here. And so our final answer here is going to be 3/32. So I thought I'd put the 1 on the bottom. So when you first write out the problem, right, you can write it as 4/1. So I just wrote it out as 4/1 here to start. And then I switched it to the reciprocal here of 1/4 after I change it to multiply. So there was still a purpose of putting it over 1, but that allowed us to flip it over. All right. Any questions about that? Okay. So let's go ahead and now do application problems. All right. And let's go ahead and see how we can attack some of those application problems based on some of the keywords that we will see in this case. Okay, so okay. All right. Okay, so let's take a look at, we're going to take a look at some tips here, of course. Uh, let's go ahead and read off this first problem here. This is on page 104. All right, so let's go ahead and read this first example off here. It says, Goldie, the manager of the Burnside Deli, must fill a 10-gallon kosher pickle crock with salt brine. She has only 2/3 of a gallon of a container to use. How many times must she fill the 2/3 gallon container and empty it into the 10-gallon crock? Okay, now first things first here. How do we know we're going to use division, and how do we know which way to write division? Because one of the things that's important is order. Order matters here when it comes to division. That's very important. So we need to figure out exactly two parts here. Exactly how do we know it's a division problem, and which way do we need to write the numbers? Okay, so let's talk about the keyword here and knowing that it's division here first and foremost. Okay. So the keyword here specifically in this particular problem is actually the phrase how many times. So how many times is going to directly refer to division. Okay, how many times do we have to take this, take this bucket and, just, continually fill it up and pour it into this other container, over and over and over again. That's essentially what division is going to be. Okay, so that pretty much is going to tell you a way that says, all right, if you see the words how many times you have to do something, okay, that's a keyword there that can certainly be helpful. Okay, we're going to see another keyword here in another example, so I'm going to definitely add to this, but that's one of our keywords here, at least to start with. Now, the other question is well, how do I know which number goes first? And how do I know which number goes second when I'm trying to go ahead and set up these division problems? Okay, so let's at least talk about that. So let's talk about a note here, actually a key here. So to know which number comes first and which number comes second, you need to know what you are dividing. So that's the first number. And by what, which is the second number. This is based on the context of the problem. Okay? So let's talk about what exactly that means. Okay. So in this instance here, let's take a look back at our problem and we'll see exactly how this works out. I'll actually make this half a screen here so we can look at the notes here and that. So, okay. So I'm going to look here for just a moment and I'm just going to kind of compare a few things. All right. So she has only 2/3 of a gallon of a container to use. How many times must she fill the 2/3 gallon container and empty it into the 10-gallon crock? So the thing that we're dividing here is we're dividing the 10-gallon crock because we want to fill up that entire 10-gallon crock full of this salt brine. Okay. And what are we dividing by? We're dividing by the 2/3 here because the 2/3 is the container that we can continue to just keep pouring out the salt brine. We need to figure out how many times we need to do that in order to fill up the whole crock here in this particular case. Okay, so when we see here, how many times we need to fill that up, that's going to be our second number. And then our full container here will be our first number here, in this case 10. So to set up this problem appropriately, okay, we're going to have here specifically, oops, I didn't mean to do that. My bad. I meant to go here. All right, go here and drag this. So what we're going to have here specifically is we're going to have 10 as our first number. We're taking our 10-gallon crock and we're dividing it by the 2/3 of a gallon a container that we keep scooping up this solution into. Okay, now doing this out here, we can rewrite 10 as 10 over 1. That's perfectly fine. And so we have 10 over 1 times 3 over 2. Again, taking the reciprocal of 2/3. Okay, and then we just reduce this down. We can divide by 2 here. All right, so this becomes 1, this becomes 5. So here we get 5 over 1 times 3 over 1. So here we get 15 over 1, or just plain 15. Okay, so 15 times, we're just going to take this container and use it to fill up the whole 10-gallon crock here. All right, and that's your final answer for this problem. Okay, any questions? Excuse me. Any questions so far? No? Okay. Let's try the next one then. So let's have you guys give this one a try. Okay? So let's try letter, yeah, let's try that one. I want you guys to try letter B. Okay, so a little bit of a challenge problem here, but B, find the number of 4/5 of a quart bottles that can be filled from a 120 quart cask. Okay, so letter B here. So I'll give you a minute or two here to go ahead and give that a try. Okay, and let's see what you guys get for that. So. When you have your answer, go ahead and just post that in the chat, and then we'll go over it together. Okay. Okay. Give you another minute here. So again, I just want you to go ahead and try letter B here. So just like a practice problem for you to try. Ola says 150. Okay. Anybody else? Anybody else want to try there? Yvonne got 150. Anybody else? All right. Let's go ahead and give it a try then and see if you guys got that same result. See if it is 150. Okay. So in this particular case, what we're going to do here is we're going to take our first number here. We're going to say find the number, okay, of 120 quart bottles. So this is another, again, type of problem here. So we have 120. That's going to be our, again, our big value here, and we're dividing that up by 4/5 of a quarts of bottles. So, all right, so we could write that as 120 over 1. So that'll be 120 over 1 times 5 over 4. We could divide by 4 here and divide by 4 here. Here we get 30, and here we get 1. So we get 30 over 1 times 5 over 1, which equals 150 over 1, or 150. Okay? Okay, any questions about that problem there? Again, type no in the chat if you'd like me to move on. So just let me know. All right. Okay. So let's look at the next part here. All right. So let's look at the next example here. So the next example here says, thank you. So the next example here says, at Child Time Daycare Center, 6/7 of the total budget goes to classroom operation. If there are 18 classrooms and each receives the same amount of money, what fraction of the operating budget does each classroom receive? Okay, so let's talk about one of the things here in terms of our keywords. Our keywords here in this case is talking about, again, receiving the same amount, okay? So you know that's even division there. Or again, what fraction does each get? So we could say, keyword here would be like, say, how many times. You receive same amount each, okay? Would be another set of keywords. Or again, what fraction. So there are several key phrases here for you to note that we are definitely using division in this case. So can anybody tell me how could we set up this division problem here for this example? What should we do? How do we set up example 5? Be very careful here. It says 6/7 of the total budget here. So there's 18 classrooms, okay? 18 classrooms here. So what are you trying to divide? Are you trying to divide 18, or are you trying to divide 6/7 from 18? So again, what you suggested is to take 6/7 divided by 18. That's what you wrote out there. So that's why it's important to note which one number comes first and which number comes second. Oops. Go back here. Okay, so in this case here, yeah, there we go. All right, so in this case here, we're going to get 18. We're going to actually do it the other way. We're going to 18 divided by 6/7. Actually, oh wait, hang on a second. I got to read that again myself. No. You can't get more of an operating budget. That doesn't make sense, does it? Because I get 21 there. Oh, actually, I take that back. I read that wrong myself. See, I'm a derp too. All right, Yvonne, I'm going to agree with you. I will divide that by 18, actually. You are correct. All right. Okay, so we're going to actually divide this by 1. So we get 6/7 times 1 over 18. We're going to divide by 6. So we get 1, we get 3. So we get 1/7 times 1/3. So here we get 1 over 21. Okay, that's right. Yeah, I get 1 over 18, and then you can convert that over. We get 1 over 21 as our final answer. Yeah, 1 over 18 to do the reciprocal there is correct. Yes. Ooh, all right. Let's try another one. I know, Eric. It would be, actually, it'd be just 1 over 21 there. Let's try another one, though. Let's make sure that we don't have pain there. Uh, yeah, I know that one's a little confusing. So we had to divide it 18 ways evenly amongst each other. That's why it's 6/7 divided by 18 over 1 here. So we did times 1 over 18 here. Yeah, only if the one's on the bottom, but yeah. Okay, fair question here. I know that's very confusing. Okay, so let's think of it this way, all right? And I'll kind of visualize it this way. Um, Imagine if you had 18 classes, right? Each one of them gets the same amount of money, okay? Then so let's say I had $18 or let's say I had $36. I'm going to give each one $2, right? So I would do 36 divided by 18 because I'm going to give each classroom $2, all right, for their, budget for whatever. Okay? It's the same idea here. In this case, the full amount of money I need to split between the classrooms 18 ways is 6/7 of the budget. So that's why it's 6/7 divided by 18 because we're dividing it 18 even ways. We're cutting it apart 18 even ways. That's why the numbers here are different. That's why the numbers here are switched. So another way to kind of look at this is if we take a look at the next one here, it says the 12 employees at some manufacturing place divide 3/4 of the annual bonus money. What fractions of the bonus money will each employee receive? So what you're making the assumption here is that every employee will receive the same amount of money. Well, we don't know exactly how much that money is, but we do know that 12 people are dividing that 3/4 evenly between all of them. So essentially we're taking that 3/4 and we're dividing it 12 ways so that way each person receives a fair and equal share of the money at the end of the day. It's like if I said, for example, here this 3/4 was, $100. If I said this was $100, I would take 100 divided by 12 and then see how much money each person got. Well, instead of it representing as $100, I represent it as a fraction, 3/4. But there's no difference on how I would do it. I would actually do it the same way. I would have 3/4 and I'd divide that by 12 in this particular case in order to see how much money each person got from a fractional perspective. So I would do 3/4 divided by 12 here and then proceed to do that there. So 3/4 times 1 over 12. And so here I get 3/48 of whatever the money was. And that's essentially how I end up doing those problems there. If I'm dividing it evenly, that whole number possibly will be the second number. That's what we're dividing by. Any questions about that? I know that one's a little confusing, so that one I admit will require a little bit of practice to kind of get used to. So I would try some of the homework problems out to get used to that. That's not super easy to do at first. So I don't blame you if you're confused on that. That's correct. Yes, Yvonne. So actually, does this reduce? I think I went fast on this. Let me check. Can I divide? Oh, 3 and 12 actually divide. That's my bad. I went really fast. This is what happens when you go fast. You become me, become really stupid. All right. So, all right. Like I'm trying to get to a certain point. That's the problem. So I kind of have to go fast here. All right. Sorry, my bad on that, Yvonne. Okay. Alrighty. All right. Next, we only got like 10, 15 minutes left, so we're going to go ahead and get through this next part here as best as we can. So let's give it a shot. Okay. So the next part here, section 2.8, talks about multiplying and dividing mixed numbers. Now, in reality, we're not going to spend a lot of time on this section, so I'm going to kind of skim it here in the next 10 minutes. Really, what's the trick here to multiplying and dividing mixed numbers? Well, multiplying and dividing mixed numbers is basically just converting it into improper fractions and then multiplying or dividing as necessary and then converting it back into a mixed number once you're done with it. So let's go ahead and put that down here. So basically, the key is convert all mixed numbers into improper fractions. Multiply or divide, and then convert the answer into a mixed number, again, if necessary. So sometimes you may get a proper fraction as an answer. That's possible, but you basically that's the whole key there, is just basically convert, multiply, divide, then convert the answer if you need to, and that's pretty much it for that. So let's do some examples here into determining multiplication and division here. All right. So let's go ahead and look at some problems here, and we'll look at like say maybe one of each. So let's take a look here. So I'll do letter B here. It says 3 5/8 and 4 4/5. Okay, let's do that problem there. All right. So we have 3 5/8 times 4 4/5. Okay, so we're just going to convert both of these particular guys into improper fractions. Again, remember to do that here is to take 3 times 8. So 3 times 8 plus 5 over 8. Okay, so 3 times the denominator plus the numerator. So just as a reminder here about how to do that, that's 24 plus 5 over 8, or again, 29 over 8. And then 4 4/5, same thing here. We're going to have 4 times 5 plus 4, which is the numerator, over 5. So this is 20 plus 4 over 5. So here we get 24 over 5. So that's what we get here. So what we have is we have 29 over 8 times 24 over 5. Again, we employ the same technique as we did before. We just say, okay, can we pare anything down? The answer is yes. I'm going to divide by 8 here. I apologize for going a little fast here, but need to get through this stuff here. I'm going to divide by 3. Divide by 8, we get 3. So we get 29 over 1 times 3 over 5. Okay. So if we do this out here, you get 29 over 3 times 3 over 5. So we do this out, we're going to get 87 over 5 here if you multiply straight across. And then convert that back into a mixed number here. So if you convert that, you can use your calculator for this, and you'll find your whole number here, in this case, to be, which was 16, 17. So 17 is going to be 85, so that'll be 17 and 2/5 will be your final answer for that problem. Again, if you're not sure, again, just take the 5 here. Again, put the 87 here. You get 1. Put in the 5. Subtract that, you get 3. Bring down the 7. 5 goes into 37 7 times. You get the 35. So you get remainder 2. Okay. So 17 and 2/5 would be your answer here. Okay, so just showing you how you would get that in that instance by just doing it by hand there. Okay, so that's a mixed number kind of multiplication type of problem there. What do we do at the last step here? We convert the improper fraction here to a mixed number. So that's the last step that we do there. So once we get the 87 over 5, we convert it into the mixed number here, which you see here. This is the work to get to that mixed number there that we got. Okay. Let's look at the next one. Got a few more to do here, so let's do that. Okay. All right. I gotta do, all right, kind of ran out of time there. All right, so let's do a division one here. Yeah, 4 and 8 divided by 3 and 3/5. Yeah, that's, well, that's not the best. I guess we could do that. Yeah, I guess that's fine. 8 divided by 3 and 3/5. All right. Or, yeah, let's do that. Oh, okay. You don't have to check if you don't need to. You could try, you could just go backwards here. Take 87 over 5, you could multiply, you can divide it by one of these two numbers. And then you'll get the other number basically. All right. So the answer is 87 over 5. Yeah, so the answer is 87 over 5, but some of the problems in the homework may ask you to write it as mixed numbers again. So then you convert the 87 over 5 into 17 and 2/5. So that's what we get there. All right. Now for 8 divided by 3 and 3/5, we're just going to change 8 to 8 over 1 like we have here. So we're going to have 3 and 3/5 here. So 3 and 3/5 is going to be, again, we convert that, that's 3 times 5, which is 15, plus 3, which is 18. So we get divided by 18 over 5. So this is going to use our same rule we just talked about here. We get 8 over 1 times 5 over 18. So we divided that by 2 on the top and bottom here. So here we get 9, and here we get 4. So here we get 4 over 1 times 5 over 9. And that equals 20 over 9. And we convert 20 over 9 into a mixed number here. Again, you could convert that here to, 9 goes into 22 times, and we have a remainder of 2. So we're going to have 2, remainder 2, and what we divided by is 9. So 2 and 2/9 in this case is going to be our answer here as a mixed number. 17 and 2/5 for the last one there. So there we go. Again, the techniques here are not going to be any different than what we did before here. Yvonne, did you see this area here that I blocked off? That's how we got the 17 and 2/5 there. Sorry, I was just in the middle of doing the question here, but yeah, this is how we get the 17 and 2/5 over here. Okay, no problem. Are there any questions about that? Hmm, that was weird. Okay. Okay. Okay, so there's some other examples here we may end up doing here for next time. A little bit out of time here for today, but I do promise to do another one here for next time, especially these word problems. And then right after that, we're going to go right into chapter 3 here. So didn't get to chapter 3 here today, but I'll start off here at the end of this section here today doing a couple of the word problems. And then then we'll do some of the adding and subtracting fractions problems here for the next go around. I think I can slot in one more type of problem though, really quick, at least a basic one. Do you want me to do a division or multiplication there, Yvonne? I can do one more because the word problems will take me a little time. So, do you want to do a division or multiplication? You can pick. Okay, let's go ahead and do one of those. And this will be our last example here for the day. I think I can fit in one more here. Okay. All right. All right, so let's do this here. I'll make it up. So how about 2 and 3/7 divided by 1 and 1/3. Okay. So let's go ahead and do this out here. Okay. Um, let's see what we get here. I'm not sure what we'll get, but I'm kind of making stuff up as I go along. So okay. All right. So 2 and 3/7 can be converted into an improper fraction here. That's 2 times 7 plus 3 over 7. So that's going to be 17 over 7. And then 1 and 1/3 is going to be 1 times 3. That's right, plus 1 over 3. So we get 4/3. We get divided by 4/3 here. Okay, that's right. So here we get 17 over 7. And since this is division, we're going to change it to multiplication and change that to 3 over 4. Now in this particular case, unfortunately for us, none of the numbers happen to pair down with each other, unfortunately, so they don't have any pairs. 17 doesn't go into 7, nor does it go into 4, and 3 doesn't go into 7 either, and 3 definitely doesn't go into 4. So we're going to multiply straight across here. So 17 times 3 is going to be 51, and 7 times 4 is 28. So in this case here, if we want to figure out what our mixed number is, how many times does 28 go into 51? That actually happens to be just one time. So here we get 23. If we subtract that, that's going to be a remainder. So our final answer here is going to be 1 and 23/28 will be our final answer for that problem. Okay. No problem. I'm here to help. Okay. So we'll do a word problem here. We'll do a word problem or two here from this section for next time, and then right into adding and subtracting of fractions. We'll get through those two sections as well. Okay, so again, 2-7 and 2-8 here for today if you want to keep pace. All right, and that'll take care of it for today, everybody. All right. I will be back in about 10 minutes if you're here for the 11 o'clock class. All right, in the meantime here, I want to thank you again very much for coming out to the stream, and I will see you all later. All right, have yourself a wonderful day. Take care of yourselves. All right, and yeah, have a good one. All right, everybody, take care. All right, we'll see you later. All right.